Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 5, part number 1 of lecture number 5. In part number 1 of lecture number 5, we will discuss the properties of matrices with respect to the addition. We will discuss different properties of matrices with respect to addition in this video lecture. The addition of matrices satisfy the following properties. First one is commutative property. With respect to addition, all these properties which are discussed in this video lecture will be with respect to addition. So commutative property, if I consider two matrices, let's say matrix A having the elements of the form Aij and matrix B having the elements in the form of Bij, both are in compact form, and let's say the order of both matrices are same, and say the order is m by n of both the matrices. So the commutative property with respect to addition is that A plus B will be equal to B plus A. So this addition in this on the both side is defined because for the addition we are required that the matrices must have the same order. So both the matrices have the same order. So this addition on the both sides of the equality are defined, and both sides must be equal. Now this is the commutative property with respect to addition. This is true for all set of matrices having same order. This commutative property is true for all. This is a notation for all. This commutative property is true for all set of matrices having same order. The same order is necessary because the addition is only defined when the order is same. So how we can prove this property? If I consider the left hand side and do some operation to get the right hand side, then we can say that left hand side is equal to right hand side and the property is proved. So for proof I am considering the left hand side, which is A plus B. Now the matrix A is Aij and the matrix B is Bij. It means that the matrix A is contain the elements of the form of Aij and the matrix B contain the elements of the form of Bij. The addition is possible because both the orders of both matrices are same. So if you want to add, you need to add the elements in the corresponding positions. So the corresponding elements will be added. So that's how, if I adding both these matrices, so actually the corresponding elements will be added. So you see that Aij will be added with Bij because both have the same subscript, and if elements have the same subscript in different sets, so they must lie in the same position of that matrices, and they are called the corresponding elements. So that's why if you are adding these two matrices, so Aij will be added with Bij because these are the corresponding matrices. Now this Aij and Bij are the elements. Remember, this Aij is the element of matrix A. This is the element of matrix A, and Bij is the element of matrix B. And you know that In this chapter we are discussing such type of matrices which contain the real numbers, the entries or the elements of that sets which we are discussed in this chapter are real number, and we know that real numbers are commutative. If you add 2 plus 4 or 4 plus 2, you will get the same result. So now if these are the elements of matrix A and B, so it means that Aij and Bij are the real numbers or the real numbers, and you know that real numbers are commutative. This is the example. If you add 2 with 4 or 4 with 2, you will get the same result. So I can write this Aij plus Bij in the form of Aij plus Bij, and the reason for this is that the elements are commutative because the elements of the both the matrices are real numbers and real numbers are commutative. Now this is the addition. Now split this. If I split this, so this will be written as Bij in a separate matrix and Aij in a separate matrix, and this is equal to B and this is equal to A. So you clearly see that this is your right hand side of this property. So you see that A plus B is equal to B plus A. So this is the commutative property with respect to addition of matrices, and this is true for all set of matrices having the same adder, and this is the proof and this is the general proof. So from this we can say that this is true for all set of matrices, but the orders must be the same, because if the order is not same, then the addition is not possible, and this property contain on the both side addition. So that's why the order must be same. So this is the first property, which is the commutative property with respect to addition. Now the second property, so this is the commutative property with respect to addition, which is true for all set of matrices having the same order. The second property is associative property. Associative property. The associative property, if we have three sets, if we have three matrices, matrix A, matrix B and matrix C, we have three matrices of the same order, mean the matrix A having elements in the form of Aij and its order is m by n, matrix B having elements of the form of Bij and its order is also m by n, and matrix C containing the elements in the form of Cij and its order is also m by n. So associative property with respect to addition is A plus B small bracket plus C, which is equal to A plus small bracket plus C. So this property is also true for all the set of matrices having the same order. And what this property says, this property says if you add the first two matrices, I am discussing the left side of this property. This left side of the property says that the left side of the associative property says that if you add the first two matrices first and the result of this addition is then added with the matrix C, mean the third matrix, or if you add the last two matrices first, and the result of this is added with the first matrix, which is A, both will be the same. Left hand side and right hand side will be the same. And remember, I explained it in some of the video in previous videos that associativity is actually a hereditary property. It comes with all the sets. It satisfies in all types of the sets. So these are the sets of the matrices. So now this is also true for the case of the matrices. What will be the proof? In general, we can also prove this. If I consider the left hand side for proof, I am considering the left hand side, and the left hand side is A plus B bracket plus C. So you know that this a plus b is in the form of this a is actually small aij, this b is small bij, and this will be added first, and then the result will be added with the this. Now you can add this, so this is aij plus bij. I already explained this point in the commutativity of the set of matrices. So you see that when you added this, then this will be added with this. So this will be aij plus bij bracket plus cij. So you see that this is get from this set. Now if you see here, this step can be written in the form of this can be written as aij plus bij plus cij. I am removing the brackets. It means that you perform this addition, and when you perform this addition you will get some number in place of this. So that's why I am removing the brackets. Now this can be written as in the form of aij plus bij plus cij. This can be written because you know that the if this is written in the split form, so this can be, because these are the numbers, and you know I already explained these are the numbers. So if these are the numbers, so in numbers mean real numbers, the associative property holds. So that's why I can write this in this fashion. Now split this, so this can be written as aij plus bracket bij cij bracket square bracket. So further this can be written as aij plus this is written as bij plus cij. I am splitting. So this is a plus this is a bracket, this is b plus c. So you see that this is the right hand side. So left hand side is equal to right hand side. So this is the associative property of the set of matrices having same order, and this is true for all such set of matrices having same order. So this is the associative property which is true in the set of matrices. So you can say that associativity or associative property with respect to addition is true for all the set of matrices having the same order. Now the third property is, this property is a plus b plus c, or you write the left hand side on the right and the right hand side on the left, it doesn't matter, because the set of matrices are commutative, so you can write. So this is also true for all such sets having same order. So these are the two properties with respect to addition. Now moving towards the third property. The third property is existence of additive identity. So for the case of matrices, the additive identity will be null set or zero set. Existence of additive identity. So if I consider a matrix A of order m by n and a null matrix, this is any matrix, and a null matrix, or which is also known as zero matrix, denoted by capital O, of order m by n. So if I add this matrix with this zero matrix or null matrix from left or from right, you will get this matrix, because all the elements of the zero matrix are 0, all the elements of the null matrix are 0. So 0 with anything you will get that. So that's why you will get A from both these addition, and this 0, which is a null set, a null matrix is the additive identity, and this is unique. Remember, this is additive identity for all set of matrices, for all matrices. So this is the additive identity. Now moving toward the fourth property, which is the existence of additive inverse. Here the additive identity is null matrix, is null. This 0 is a null matrix, mean 0 matrix. This is capital O, which is used for the notation of the null matrix. The fourth property is the existence of additive inverse. The existence of additive inverse. So if we have a matrix A of order, let's say m by n, this is a matrix A, and we find the negative of this matrix. So the negative of this matrix is denoted by minus A, minus times A, and the order of that must be same, because negative of the matrix is actually obtained by multiplying, by doing the scalar multiplication, mean you are multiplying -1 with the given matrix. So if you find out the negative of a given matrix, this is negative of a given matrix A, and then you add original matrix and negative of the original matrix, either you add the original from the left or from the right. So from both the cases you will get additive identity, and the order of that additive identity must be the order of the matrix A. So this must be of the order m by n. So this is capital O, null matrix. So this is additive identity for the matrices. So whenever you get from some addition additive identity, so then those two matrices must be set the additive inverses for each other. And remember, every set has its own additive inverse, but additive identity is unique for all matrices, and every matrix has their own additive inverse. So from this you get additive identity. So that's why whenever from the addition you get additive identity, then these two are said to be additive inverses. So remember that the negative of a matrix is actually the additive inverse of that matrix. So this is an important point for eta, important point from eta, which we conclude from this the existence of additive inverses, that negative of a matrix is additive inverse of that matrix. So this is these are the properties of matrices with respect to addition. Commutative property true in the for all the set of matrices having same order. Associative property is true for all the set of matrices having same order. Existence of additive identity. So null matrix is the null matrix or 0 matrix the additive identity, and taken its order with the same as the order of the given matrix, and the existence of additive inverse is actually negative of a given matrix. So these are the properties with respect to addition. Thank you.